Hi, welcome to my video on extras with Trig. So extra couple of problems that I'm going to do the derivatives with some Trig with implicit differentiation. Find y prime if x cubed plus tan of xy equals 4. So y prime is the first derivative, so it's d dx. So that's a 3x squared plus the derivative of tan is secant squared of the function xy, and now I have to do, because of the chain rule, derivative of xy. So the derivative of x is 1 and times y plus x times the derivative of y is 1 y prime, so it's just y prime, and the derivative of 4 is 0. So this is 3x squared, and I have secant squared xy times y. So let's squeeze that back here. So that's a y, so put the y in front of the secant squared, and this is a plus, so it's x y prime secant squared of x y equals 0. Now I have to isolate the y prime. The y prime is right here, so that means I have x y prime secant squared x y. So the y prime is isolated, there's only one there, so I have a negative 3x squared plus y secant squared xy. So this stays here, and these two move over to become a negative and a negative. Whoop, see that? Just check my work, and I left plus there, I didn't change the sign. So that's negative 3 here, and there's a negative y here. And now we divide by y prime is negative 3x squared minus y secant squared of x y, and is divided by x secant squared xy, x secant squared xy. So just again a different problem with some trig in it, and we have the product rule and the chain rule here, so it's a little problem that has everything. And number 2, express y double prime, which is the second derivative, as a rational expression in terms of x and or y. Reason I say x and or y, because this double derivative could have all x's, could have all y's, could have x's and y's, so it's x and or y. We won't know until we're finished. If 4x minus sine y equals 1. So first derivative is a dx is a 4. Derivative of sine is cos, so that's cos y, and the derivative of y is y prime. Derivative of 1 is 0. So we have 1, so we have cos y times y prime equals negative 4. So y prime is equal to negative 4 divided by negative cos y. So y prime is equal to 4 over cos y. So that's the first derivative. Now we'll do the second derivative. So the second derivative, here comes the second derivative. Again, there's a d dx on this expression, this equation here, so d dx. So that's, I could make that a negative, but I'll leave it and use it as a quotient rule. So let's go. Let's see what we have here. So the derivative of 4 is 0 times cos y minus 4. Derivative of cos y is negative sine y, and the derivative of y is y prime, and that's all over cos y squared. And so let's simplify that. So 0 times cos y is 0, and so this is negative times negative times negative positive, so it's a positive 4 sine y prime over, now I could go cos y squared, I wrote it as cos y all squared, so that also could be written as cos squared y. Just wanted to show that. I could have wrote that down at the beginning, but I didn't. I just wanted to square it first and then change it after, so you can see that this expression here, cos of y all squared, is the same as cos squared y. Now we want in terms of x and or y, so 4 sine y. The derivative of y is 4 over cos y, so 4 over cos y divided by cos squared y. And if we want, we could simplify this. We get 16. Let's go right here. We get 16, and we got a fraction, so we could make it 16 sine y over cos y divided by cos squared y. So I multiply these two together. This is understood to be over 1. So 4 times 4 is 16 sine y over cos y. So now that's over 1. So we can multiply, do the flip, or we can multiply by cos y top and bottom. Or I can, again, I'll do it. I'll go cos y, and that gives us negative 16 sine y. That cancels out all over cos cubed y. That's one way. The other way to do this right here, instead of multiplying by cos y over cos y, which is a fast way to eliminate cos y here, the other way is to do this, 16 sine y over cos y. So that's the numerator. Having it over 1, you can multiply by the reciprocal of 1 over cos squared y. And now when you multiply this out, you get this. So there's two ways. You can take this expression and multiply by cos y over cos y, and the fractions are gone, just left with this. This is a complex fraction. It's a fraction in a fraction. Or you could take the numerator, multiply by the reciprocal at the bottom, your choice, but you'll still get the same answer. So that brings us to the end of my videos. I got one more to do, and that video is on the review of the whole unit. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content I have on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.